We have a couple of other types of equations that we have to solve that involve exponential and logarithmic functions. So I'm just going to go through a few of these problems and then the expectation is that you finish the rest on your own. So notice here it says, what happens when I have unlike bases that cannot be rewritten? We discussed this a little bit last class, that when I don't have bases that can't be rewritten when they're not the same, all I do is I just pick any base and then I just use the change of base formula. I'm essentially doing the same thing here. So if I look at number 1, I notice that base 6 and base 10 cannot be rewritten to have a common base. So I'm just going to multiply both sides by any logarithmic function that I want. I can use the natural logarithmic function if I want, or I can use log of any base. So because the famous log base is 10, I'm just going to multiply both sides by log. So then the base is 10. So this will say log base 10 of 6 to the 3x minus 1. And that equals, and then I'm going to do log base 10 of 10 to the x plus 7. So if I look on my left-hand side, log 6 to the 3x minus 1, whenever I have an exponent, I can bring it down and make it a coefficient. So now I have 3x minus 1 times log of 6. And now if I look at my right side, log base 10 of 10, that makes 1. So now I'm left with x plus 7. So sometimes when your bases cannot be rewritten, maybe it's smarter to multiply both sides by log when one of the bases will cancel out. Maybe makes life a little easier. So now I have 3x minus 1 times log of 6 equals x plus 7. So I'm trying to get x by itself. So I'm just going to go ahead and I'm going to distribute this. So I have 3x log 6 minus 1 times log 6 is just negative log 6 equals x plus 7. So now I'm going to move all my x's to one side and all my y and all my constants, my non-x's, to the other side. So I'm going to subtract this x to the other side. So I have 3x log 6 minus x. And since negative log 6 does not have an x, I'm going to add it to the other side. So I have 7 plus log 6. So now if I look at my left-hand side, I can factor out an x. There's an x in common. So if I factor out an x, and I'm very nicely running out of room here, but if I factor out an x, I'm left with 3 log 6 minus 1 equals 7 plus log 6. So now if I want to get x by itself, it's just x times 3 log 6 minus 1. So I'm just going to divide by all of that. 3 log 6 minus 1 divide by 3 log 6 minus 1. So if I didn't have a calculator, x would just equal 7 plus log 6 over 3 log 6 minus 1. But if I did have a calculator, which I do, I'm just going to type all that in my calculator. I recommend doing pieces so you don't mess up, or I recommend using the alpha y equals trick to get that pretty fraction bar. So I'm going to do 7 plus log 6, and I'm going to divide that by 3 log of 6 minus 1. And when I hit enter, I get 5.829. So x, let me not write in a highlighter. X equals 5.829. And if I had to multiply by the natural log instead of log in the beginning, you would have gotten the same answer. It just would have taken you a little bit more work. All right, so now I'm going to skip around. I'm only going to do a few of these with you, and then you can do the rest on your own. So I'm going to go down and I'm going to do number 3. Let me erase all that. And I'll zoom in a little more so we have some more space. All right, awesome. So notice my bases are the same, or not the same, and I can't rewrite 5 to get 10. So I'm just going to multiply both sides by a common base, by a common base logarithm. I'm just going to do log base 10. So now I have log base 10 of 10 to the x plus 5 equals log base 10 of 5 to the 3x minus 4. So I know log base 10 of 10 cancels out, so I'm left with x plus 5 on the left. And on the right, I can move 3x minus 4 to be a coefficient, and then I have log 5. So now I'm going to go ahead and I'm going to distribute. X plus 5 equals 3x log 5 minus 4 log 5. So now I'm going to move all my x's to one side and all my y's to one side. So I am going to keep x on the left, and I'm going to move 3x log 5 by subtracting it. 3x log 5. And then I'm going to move negative 5, so move negative 5 to the other side, and then I have minus 4 log 5 as well. So now I'm going to factor out an x. So I'm left with 1 minus 3 log of 5 equals negative 5 minus 4 log of 5. Divide by 1 minus 3 log 5. So those cancel out. So I'm left with x equals negative 5 minus 4 log 5 over 1 minus 3 log 5. And again, if I didn't have a calculator, I would leave my answer like that, but I do have a calculator. So I'm going to type in negative 5 minus 4 log of 5 over 1 minus 3 log 5. Oops, hitting wrong buttons on the calculator. I get 7.107, so x is approximately 7.107. So you can do this, you could round technically to any decimal place, but 3 digits is just what I think is the general rule of thumb. Unless otherwise stated, it really doesn't matter. So I'm not going to go ahead and I'm going to do number 5. So number 5, I have log x of 8 equals 3. So when your variable is your base, I recommend just turning this into exponential notation. If I turn this into exponential notation, remember it's x cubed equals 8. So now cube root, x equals 2. Done. If I look at number 6, my base is x minus 2 squared equals 16. So now if I look at a problem like this, what am I going to do? Well, this I'm going to have to FOIL, so scribble that out, write x minus 2 again. So now I have x squared minus 2x plus 4 equals 16. So now if I clean everything up, x squared minus 4x plus 4 equals 16. So x squared minus 4x minus 12. I know I'm going to have to factor because I have a quadratic here. So x minus 8, nope. How about x minus 6 and x plus 2 equals 0. So x equals 6 and x equals negative 2. And if I go back and plug these in, because it's a logarithmic function, negative 2 would not work. Because then I would have negative 4. So I'm finished. So I want you to go ahead and you're going to finish these next 3 problems. 2, 4, and 7 you're going to do on your own. And then the answer key is on Google Classroom for you just to go ahead and check your answers. If I'm going to jump down, I'm going to do this one word problem up here, and then you're going to do the word problems on the back. So it says, suppose you find a bank account that invests 6% annual interest compounded continually. So remember, when it's compounded continually, it's A equals PE to the RT. You have to know those formulas. So what should your initial investment be if you want to make $12,000 in 4 years? So if I want to make $12,000 in 4 years, so that's how much money I want to make. So that's A. What my initial investment is, that's P. I don't know what P is. But now I have E to the R. R is my interest rate, so it's 0.06 times T, which is 4 years. Remember, t has to be in years. If it's in months, you have to figure out how many years that is. So I'm not going to figure out what 0.06 times 4 is. That's 0.24. So now I have 12,000 equals p to the e to the 0.24 power. So now how to get p by itself, I'm just going to divide by e to the 0.24. E to the 0.24. So I have 12,000 divided by e, 0.24 power, hit enter. The amount of money I would have to initially invest is $9,439.53. So about $9,400 is what I would have to deposit in order to get $12,000 in 4 years. So now it says, how long will it take for your initial investment to triple? So if I want my initial investment to triple, I want 3p at the end of it, right? So 3p is a, so now I have pe to the rt. So 3p equals pe. My interest rate is still the same, but now I want to figure out how long, so that's time. So I'm going to divide both of these by p. So now I have 3 equals e to the 0.06t. So to get t out of my exponent, I have to multiply by the inverse of its base. Its base is e. So I have to multiply both sides by ln. So I have ln of 3 and ln of e to the 0.06t. So ln and e cancel out, so I'm left with ln of 3 equals 0.06t. So now I'm going to divide by 0.06. So now in my calculator, I'm going to type in ln of 3 divided by 0.06. T is 18.3. So in about 18 years, I expect my initial investment to triple. If I look at the last one, it says, suppose a separate account has a different interest rate, yet still compounds interest continuously. You deposit $1,000 and 8 years later have $1,800. What's the interest rate? So, okay, I'm still using P equals A. Nope, I'm writing all these backwards here. Let's erase that. A equals my initial investment, E to the RT. So how much money I end up with is $1,800. My initial investment is $1,000. Now I have E. R is my interest rate. What is the interest rate? That's my variable. And in how many years? T is 8. So let's start getting R by itself. I'm going to divide by 1,000 on both sides. So now I have 1.8 equals e to the 8r. So now to get r out of the exponent, I'm going to multiply both sides by ln. So I have ln of 1.8 and ln of e to the 8r. So ln and e cross out, so I'm left with ln of 1.8 equals 8r. So now I'm going to divide by 8 on both sides. So r equals ln of 1.8 divided by 8. I get so r is 0.0735. So to turn that into a percent, it would be 7.35%. So go ahead and finish the back of this worksheet, and the back is, the answers can be found on my Google Classroom page for you to be able to check and reference.